ngelihat apa namanya dinamika ini batu bara ini harga batu bara.
Ya, ya, ya. Tapi menarik itu.
Iya ya. By the way Pak Jarod yang berapa kemarin atau 2 hari yang lalu yang di acara BRIN itu yang
Carbon footprint?
presentasi ya betul
Yang carbon footprint ya?
carbon footprint, nah betul. Kalau boleh di sharing ininya soft copy-nya presentasinya Prof. Jarod.
Oh, boleh, boleh. Saya nanti share di mana? Bentar.
Email atau WA?
Oh, baik. Pak Sarwi, saya kira saya punya nomor WA-nya Pak Sarwi kan?
Ada. Saya kan nerima undangan sekarang
Oh
ini juga
ya.
dari.
Oke, nanti
Ya.
saya kirim ya Pak ya.
Iya. Iya.
Ya, ini sekarang baru banyak membahas nuklir, macam-macam ini skenario-nya. Tadi saya baru pulang dari Jakarta membahas green hydrogen production.
Ya, hidrogen juga itu. Berapa ya? Kira-kira 2-3 minggu yang lalu tuh pas ada roadshow untuk B20 ke Eropa, itu
Oh,
ketemu ada dari orang Belanda itu yang itu juga rasanya justru lebih percaya pada itu hydrogen fuel.
oh, tapi hydrogen fuel kan harus ada yang memproduksi nih.
Oh iya betul. General Electric juga saya dengar mau fokus untuk pengembangannya ke sana karena kalau seperti wind turbine gitu secara bisnis itu barrier to entry-nya rendah gitu. Jadi dikhawatirkan dalam waktu singkat tidak bisa bersaing dengan negara-negara seperti Cina dan seterusnya gitu.
Oh iya sih, ya. Memang ini menjadi tantangan tersendiri. Indonesia itu tadi kita membahas, rupanya masih semuanya serba ide.
Iya.
Roadmap-nya juga
Termasuk
belum.
yang mau coba ditekuni oleh GE itu setahu saya juga nuklir itu.
Oh.
Saya pas di sana, pas di Brussels itu ketemu dengan siapa itu Prof. Antonio, siapa dari GBA Consultant itu malah justru sangat mendorong nuclear power generation.
Ya, ya moga-moga lah. Kita tunggu saja ini.
Ya.
Saya hadir Pak Ketua.
Ketuanya belum hadir malah
Ya, belum. Baru Pak Jarod.
Saya
Saya pikir tadi Pak Ketua. Oh Pak Sarwi rupanya. Saya pikir Pak Ketua saya. Apa kabar Pak? Sehat Pak? Pak Sarwi sehat?
Gimana?
Ya beginilah. Ngikutin Profesor Jarod aja saya. Kalau ngikut beliau kan aman saya Pak.
Ya Indonesia itu aman lah.
Aman terkendali ya Pak. Saya itu kan berdoa terus sepanjang hari, sepanjang malam supaya Bapak Jokowi kita selamat dalam perjalanan.
Iya. Ya, di Ukrainanya selamat. Kayaknya udah balik ke Polandia kan?
Oh, langsung ke Moskwa.
Oh, langsung ke Moskow ya?
Pindah kereta api langsung ke Moskwa.
Oh.
Ntar lagi juga nyampe lah.
Oh,
ya. Terus saya dulu naik kereta api dari Helsinki, saya naik kereta api ke Moskwa.
Ya.
Perjalanan yang menarik.
Moskow itu bagusnya adalah stasiun kereta bawah tanahnya itu indah.
Alamak, luar biasa itu Pak.
Iya, luar biasa indah itu.
Iya, luar biasa itu Pak. Ya. Tapi kalau nona-nonanya jangan lihat di Moskow, lihatnya di Saint Petersburg.
Oh, Pak Utama itu hebat itu.
Ya kan semuanya yang cantik-cantik kita lihat Pak, stasiunnya, nona-nona. Kalau di Moskwa itu kan nona-nonanya sehat-sehat, Pak. Oh, sehat-sehat. Kalau di Saint Petersburg ayu-ayu kayak mojang parahyangan.
Okay. Hello, Dr. Raymond. How are you?
Fine. Good afternoon with all of you.
Yeah.
Nice to see you all. And
Yeah.
Professor, thank you for arranging this webinar. I think we are in a very critical phase in the world.
I think so.
And I think the rich countries will not help us out of this problem. And I think countries like Indonesia have the best opportunities to show the world how we can make a better world.
Sure. So what time now in Netherlands?
It's now 11 o'clock in the Netherlands.
11. It's
in the morning, ya, Pak.
In the morning.
Morning.
In the morning.
Yeah. So in the morning. That's good. So do you ever went to Jakarta or Indonesia before?
Well, I have been in the around just at the crisis, the Asia crisis. I was in Indonesia and I did meet Dr. Subki and Dr. Bakri. This is a picture with them in Bali.
Okay. Yeah.
Because we wanted to start this technology in that period in Indonesia. Indonesia had big plans to do this, but then the Asia crisis stopped it.
Mm-hmm.
And I feel very bad because if that project had continued, then Indonesia would be the leader in this technology now in the world, and that is now China.
Mm-hmm.
And but anyway, we can do better, because I think with small reactors we can even improve the performance of the plant compared with the big plant.
Yeah.
And,
I think now Indonesia, the situation for nuclear is very well. I think I am very optimistic with the future of nuclear energy in Indonesia. And there are a lot of vendors coming to Indonesia to meet the government agencies. You know, maybe the NuScale, the Last Energy, of course, the giant like Rosatom and Westinghouse also want to promote their technology. Well, I hope 10 Energy has the same activities for this conducive situation in Indonesia.
Yeah, I think in the my feeling is that Indonesia is the best place. I just was in India in May, and I told the Indians that they can change the world. They can bring peace in the world. But afterwards, looking at the history of Indonesia, I think Indonesia has better opportunities than India, because this technology is not known in India. They are now beginning to look at it. But you have about 10 to 20 years experience in it already. And you have people even at the Atomic Energy Agency working in this field. So yeah, Indonesia is the best place in my view now. Because politically in India, it goes very slow. I think in Indonesia, you could move very fast. And we need a fast decision, because I saw some troubling developments here in Europe on the BBC and CNN, where the G7 came in Germany to talk about, I don't know what they were talking about, but the only thing I heard is that they want to boycott Russian gold export. They have to solve the energy problem for the world, and look what they are talking about. And after that, they went to Spain for a NATO conference to see what has to happen now that Finland and Sweden will join NATO. So the decision is that they will go from 40,000 soldiers at the border to 300,000. These are no good signs for the world. And
well, I think you have to save your explanation after starting the webinar.
Okay.
Please,
okay.
You can explain the situation and the recent situation. Okay. Okay, we still have 2 minutes left before we start the webinars. We are still waiting for the chairman of Indonesian Nuclear Society. Okay. I don't know. where he is. I hope he already joined us. Or maybe, oh, Pak Yarianto?
Ya, Pak.
Yeah, if Pak Susilo Widodo cannot join us, would you please well, on behalf of the Indonesian Nuclear Society, to give short speech, because your expertise is on the nuclear energy.
Okay, thank you very much, Pak Jod.
Okay.
And,
But wait, because we are still have 1 minute left before we start.
Okay, no problem.
Okay.
Okay.
Yeah. Okay. I will start this webinar. Dr. Raymond, I would like to speak in Bahasa Indonesia first. Then I will use the English for the whole webinars.
Yeah, okay.
Selamat sore Bapak Ibu semuanya. Kita ketemu lagi dalam webinar yang ke 25 atau 111 sepanjang 2 tahun ini. Jadi minggu lalu adalah ulang tahun dari webinar kita di bawah Wisnu Broto Labs. Kita sudah hampir setiap Kamis, kadang Jumat juga mengadakan webinar. Kali ini kita akan membahas nuklir energi. Ada suatu perusahaan namanya Ten Energy menawarkan banyak hal, mungkin kita dengarkan dan mungkin boleh bertanya. Saya pun dalam posisi terbuka, mungkin menawarkan bagaimana kalau PLTU itu segera bisa diganti dengan PLTN dengan beberapa teknologi, apa itu STGR, apa itu kemungkinan penggunaan thorium dan lain sebagainya. Saya akan menggunakan bahasa Inggris sebagai pengantar, tapi kalau mau bertanya silahkan menggunakan bahasa Indonesia atau bahasa apa saja, nanti bisa dibantu pakai Google Translator untuk menjadi berbahasa Inggris. Okay, I would like to start in English. Good morning in Netherlands, good afternoon in Indonesia, and good day everywhere that you can join our webinars, weekly webinars, the Wisnu Broto Lab webinar. And today we have a special guest from far away from Indonesia, from Netherlands, Dr. Raymond Pahladsingh. I'm sorry if I spell you wrongly. He is the founder and CEO of Ten Energy. I think, as I said before begin the webinar, the situation of nuclear energy, the future of nuclear energy in Indonesia is very optimistic because we have the roadmap. We have a target on to 2060, reaching the net zero emission. And nuclear energy is one who will give a big player or give the contribution to reach that net zero emission target. And there are a lot of vendors coming here in Jakarta recently, such as NuScale, Ten Energy. Well, Ten Energy is the new player, I think, but they have already important counterpart in Indonesia. Besides that, the big name like Rosatom, Westinghouse also promoting their technology. But today, we have special guests that want to promote what Dr. Raymond said, green revolution or something, that we want to change the coal power plant using the nuclear technology. Even he says about possibility to use the thorium fuel. But before we begin the webinar, as usual, I would like to ask Mr. Yarianto on behalf of Indonesian Nuclear Society, because Mr. Yarianto is, well, his specialty is nuclear reactors. He has a lot to do. Well, in the past, he did many things on the feasibility study of nuclear power plant in Indonesia, in Bangka, in West Kalimantan, including he has an experience also on the uranium and thorium exploration. Please, Pak Yaryanto.
Okay, thank you very much, Pak Jarod. Good morning for Mr. Raymond, and good afternoon all of participants in this webinar. I would like to thank you, Pak Jarod, and also all the participants. This is a surprise to me because
sorry to ask you.
really surprised because no Pak Susilo Widodo, so that's I was appointed by Pak Jarod to give speak. Representative of Pak Susilo Widodo as chairman of Indonesia Nuclear Society. I think this is the a good events for the webinar, and this is the opportunity, good opportunity to invite the speaker from TEN Energy, Mr. Raymond. Maybe we will hear about the opportunity for developing the nuclear power plant in the future with the technology that developed by TEN Energy. I think this Pak Jarod said that many nuclear power plant developer or designer have come to Indonesia to offer the technology. And this is interesting because the thorium may be based of your fuel energy, and this is, I think, compatible with the future energy sources, because we should calculate about the resource, the resource of nuclear fuel. We know that now the uranium is maybe the widely used for the nuclear power plant, but the thorium still developed. So if the future the thorium will be used, I think this is the opportunity for Indonesia also to participate on the nuclear fuel business, maybe, because in Indonesia, based on our survey, is much more than uranium, although this is still hypothetical resource, not measure resource, but I think this is give our expectation in the future. The key technology for the thorium is, I think, also for the extraction of thorium and also to processing until the nuclear grade, and maybe developing for the nuclear power plant technology itself. So maybe we will have a good opportunity in this afternoon, because maybe we have other choice for the nuclear power plants. Maybe for the thorium is like molten salt reactor, also based on the thorium, and maybe STGR also maybe blended or mixed with the thoriums also possible. So maybe we will hear or listen your presentation about your technology and how the possibility to be implemented in Indonesia. I think thank you very much for Mr. Raymond for your join with us to give the presentation or maybe the information to us. HIMNI or Indonesia Nuclear Society is one of the organization that have vision for educating public education, and also the information to public about the nuclear technology, not just for the nuclear power plant, but also for the application of nuclear energy, such as for the food, yeah, for water, for environments and others, or industry. Thank you very much for joining here for everyone. I think this is my speech. Terima kasih Pak Jarod dan Pak Susilo Widodo yang sudah saya wakili.
Pak Susilo belum muncul.
Oh,
terima kasih kami yang Pak Ya.
Okay, thank you very much Pak Jarod.
Yeah.
I think it's,
terima kasih. Thank you Pak Yaryanto for your speech on behalf of Indonesian Nuclear Society. Pak Yaryanto is very experienced person on the nuclear energy program in Indonesia, because he was the director of Nuclear Energy Assessment Center, and then he also once the director was the director of the uranium or nuclear geology center, the activities on the exploration of uranium and thorium. That's why he knows well when we want to talk about the sources, the uranium and thorium resources, how much we have and other things. Then maybe he will also ask Dr. Raymond about many things. As usual, I would like to show you a short video clip about the invitation to be the member of Indonesian Nuclear Society. Okay. Well, I think it is time for Dr. Raymond to give the explanation. The time is very flexible, maybe about 40 minutes, it's okay. And we have still time for the discussion. Please introduce yourself, your company, your technology, and because the audience is very, well, wide variety of background, some scientists, some engineer, but some who are enthusiastic on the nuclear, but they don't have the background, academic background. Maybe I would like to ask you to use the language of, well, to avoid the technical words or technical terms. Please, Dr. Raymond. You still mute yourself. Please unmute.
Hello, you hear me now?
Yes, okay, yes. Yeah.
I was on mute, so sorry. Good afternoon, everybody. Before I introduce myself, I want to say that I was born in Suriname, South America, where a great percentage of the population is also Indonesian. So we know quite some things from Indonesia and Suriname, especially the food. We have very good Indonesian restaurants in Suriname.
Oh,
and,
maybe you can speak Bahasa also Bahasa Indonesia.
No, I know a few words. Yeah.
Okay.
But yeah, to come back to Dr. Yaryanto, his speech, there are many companies who are coming into Indonesia, yes, and I think we need all nuclear options that are available, from pressurized water, boiling water reactors, molten salt reactor. Everything that we need can make is welcome, because all of the nuclear reactors, they produce zero CO2 emission. But especially for Indonesia, we have to consider the seismic activity and the structure of the country. These are islands, so you have to look. Actually, small nuclear reactors would be ideal, especially if you can put them on barges to move them around in Indonesia. And I want to especially mention Dr. Heinz Nabilek, his work that shows that the STGR can be used for uranium, thorium, MOX, any type of fuel can be used in this reactor. That is the nice part of this reactor. And for all the fuel types, the performance is that it is absolutely safe. I'm a specialist in safety of nuclear reactors in the nuclear engineering, and I was assigned to work with General Electric on the ESBWR, and I was responsible for the safety of the design. So the probabilistic risk assessment of the General Electric reactor, I had done that work. The unique thing of our technology for Indonesia is that with this, if we select this technology, we also save the coal industry, because you need massive amounts of graphite in this reactor, and you can save the coal industry by going towards graphite, whereby the added value of the product will be maybe 1,000-fold. What is happening now in the world, that everywhere they want to close the coal-fired plants, and on the COP26 conference, they wanted to sign an agreement that we're going to close the coal-fired plant, but the Minister of Environment of India blocked that. And now that whole COP conference is now, yeah, you can throw it away, because the countries that ask for closing the coal-fired plants, they are opening the coal-fired plants again. Germany, the Netherlands, UK, all these people who were so against coal-fired plants now are running their coal-fired plants again. So this was my introduction, that this technology should be looked in a different way, because it's, well, I think the first technology I know that supports also the existing energy infrastructure, not only in Indonesia, but in India, in China. So this technology, you have to look in a different way to it. And also the Atomic Energy Agency has published a report 1366 about the high temperature gas-cooled reactors, that regulatory bodies should look in a different way to this design, because the defense in depth for this type of reactors is quite different from the current reactors. That is all I did in the past since 2007 to work on absolute safe reactors. And I tried to promote this technology in many countries, and I even went to Brazil. The chairman of the Nuclear Society there, Antonio Muller, called the STGR the chicken with the golden egg. So that's nice to hear that, but the regulatory body in Brazil doesn't allow private companies to do nuclear energy, so we could not proceed there. And struggling all over the world with this technology, new technology is very difficult to promote, because you have an establishment that doesn't work with you. Then came the climate crisis, and last year the government in the Netherlands decided that the 4 brand new coal-fired plants, not even 5-year-old, had to be closed. And after that came the COP26 conference that said we have to phase out of the coal industry. But that is not what the COP21 has said. The COP21 had said we have to decarbonize power generation, and that is something else than like closing coal-fired plants. But the lobby was there quite wrong. But these two things made me think about what to do, because I had been working on this reactor to replace coal-fired boilers. And these two things made, when I heard the thing that the Dutch government wanted to close the coal-fired plants, I immediately responded that that is not allowed, because you have very good engineering solutions to convert the coal-fired plant to any other type of plant, and in this case, to replace the coal-fired boilers with the steam nuclear island of the high-temperature gas reactor. And I think that made a big change in the decision-making process here in the Netherlands, because at the moment, just before the war of Ukraine, it was decided that the plant will not close. And we were aiming at the Riverstone coal-fired plant, which is 730 megawatt. So that was for me the opportunity to start a thinking process. Let's start the green revolution in power generation and green hydrogen in Rotterdam, because if I can get that power plant, I have the ideal location for all the types of products that can come from the reactor. You can make power, you can provide heat, you can provide purified water, you can do many more other things in Rotterdam. So all the nuclear reactor, the power plant, conversion of the power plant in Rotterdam would be the ideal place to begin. That's why I call it, let's start the green revolution in Rotterdam. But for a revolution, you need more than the power plant. You need the fuel. And in my presentation, I have put a picture where I put for the fuel, I put for India 7 points, which are needed to make a revolution successful. You need, of course, in this case, thorium. 10 stands for thorium energy networks. That's the way we got to the name. You need the thorium in big quantities. India has, I've mentioned India, but Indonesia could do it also, because Indonesia also has quite a lot of thorium. Scientists and experts, India has them, but the ones in Indonesia are better because you have people who have worked on this technology already. So that is an advantage. You need ICT, you need the brain power, and that is also in Indonesia. You need the heavy industry, and I think you have it there, but you can also ask it in countries like India. In India, the heavy industry could make these reactors also. You need, of course, a lot of manpower. Indonesia has sufficient manpower. The advantage is in the nuclear industry, you have to speak English. That's why Indonesia or India are better than China, because in China, if you don't speak Chinese, you don't come anywhere. Nobody understands you. And the last but not least, and I think that is the most important at this moment, is that you have quite a track record in research and development of this technology. These are the things why I think Indonesia is even better than India, because the decision-making process in India is slow. I think you could move fast in Indonesia. And yeah, that's why I'm very happy that I'm talking with you today. And if we don't succeed, I don't know if you can see it. This picture is from the UK Atomic Energy Agency in 1989 in the book Atom. And they describe what will happen with the planet if we don't come with good solutions for global warming. As you see, the black parts are the places that will become desert.
Do you want to show your presentation, or can I help you to?
If you have it, then otherwise I can. Will it be possible?
I already have your materials for presentation. Can I help you to operate your PowerPoint? Is it okay?
But yeah, if you can put it for me on the screen, then I can go through it, because that can be helpful.
Okay. Please wait. I will show your PowerPoint that I have already got from Mr. Sayaf. Please wait. Okay.
Yes. Can I go and continue?
Yeah, please.
Okay. This is the front page which I made after I received your webinar invitation. I think the title is also very nice, Global Green Revolution, STGR with thorium fuel. But the reactor can use many fuels, as I mentioned to you, and Dr. Nabilek did make a very good paper on that. The next page is, yeah, this is what I made for Rotterdam, that the green revolution, we want to start in Rotterdam because of the problems we had here in the Netherlands. And one of the main things is how we start with the idea of the green revolution is in November of last year, we had sent in our proposal to the World Hydrogen Energy Summit in Delhi, and it received the prize for the most green hydrogen that is produced in the world. So there were very big multinationals there, but this technology received the best prize for green hydrogen. So I think we were very glad with the prize, and we used that also to construct the idea of the green revolution in Rotterdam. Next page, please. Yeah, this message I did write to the organization committee of G7 that listen, most likely this G7 conference is the most important one because we have to stop the war between Ukraine and Russia. And the G7 they are powerful, they have all the money, and so they can tell us how they can provide energy to 7.8 billion people today, and how they will provide energy for 9.8 billion people in 2050. And they have to follow the constraints of COP26, because COP26 wants us to reduce CO2 emission in power generation with 50% now in 2030. And fossil fuel power generation must go to 100% CO2 reduction in 2050. This is something I don't think is possible in a simple way, but I think we can do it if we start with the conversion of the coal plants. Next, please. Yeah, I put this slide about India. The reason why I was in India and I told the Indians that you only can help the world because of these points. And they were surprised that I came up with the remark that they can help the world. But I showed them this, and finally they accepted it also. India has all these 7 points which are needed in a green revolution. You need a lot of young people. Europe and America cannot come with a revolution. We are all too old here. These are aging societies. They cannot come with a revolution. India can do it. And Indonesia also. Next slide, please. I think the next one is for Indonesia. Yeah, 0.8. Even India has not 0.8. You have it, and I think you must use it to the maximum. And if people from the scientific group of Batan and other organizations of Indonesia want to work with us, yes, please, let's do it together. But as you see, only India and Indonesia have these 2 qualities that are number 1 and number 8 are very important for the new fuel for the future. And that's why my focus is on India and Indonesia. Next slide, please. This was in May published that nobody is doing anything to stay within the 1.5 degrees Celsius limit. All the countries that promise something, they are not doing what they have promised. So if you are not doing anything, I think we will end up in the next slide. Next. This slide is from 1989, out of the publication of the UK Atomic Energy Agency in the magazine Atom. You see all the red colored parts will be flooded in 2088. The dark places will be new deserts, and we'll have over 9.8 billion people on the planet to live. This is a very disturbing picture, but we are not doing anything to stop global warming. So we have to work very fast with very good solutions to stop this type of development. Next, please. Yeah, I found this on internet on how our energy market looks like at the moment. For electricity, we have 2,200 gigawatt of coal. I think converting the coal is the most easy way to try to meet the 1.5 degrees Celsius, because within 3 years we can convert the whole coal-fired plant, because you only have to replace the boiler and you use the same plant. And that's why I say for Indonesia, this is an ideal solution. We have to look at it, and if Indonesia wants it, we have to start as quick as possible. Next, please. Yeah, because suddenly everybody started to open the coal-fired plants again, I had to say something to the people that, listen, the STGR is not to improve your environment or for CO2 reduction. It is the economics makes STGR the best solution. The environment things are just a bonus you get, but since nowadays the environment was so important, we use that also to promote our technology. But our technology is not for the environment; it is for the economics, and the other things just come with it. Next slide, please. You see here, I compared STGR and the big plant I want to convert in Rotterdam. What will happen if you convert the coal-fired plants to STGR and the Onyx plant? The last two columns are the two converted plants. And here are all the prices of all the so-called great green and fossil fuel power generation costs. And you see that the generation cost of a new STGR is $6.8 per megawatt, and for the big plant, $3.2 per megawatt, because of the additional projects you can make. That's why the price goes very low. So if we take a reference coal-fired plant and we take the NEA numbers, the line 1 in the top, and we calculate the savings in generation cost, an STGR 20 for 40 years will produce 690 million in savings, and the big plant will save 20,799 million. So these technologies cannot compete with the high temperature gas cooled reactor. So I just put this because if the people ask me, yeah, we can start the coal-fired plants again, then I can tell them that look at the price you have to pay and compare it. Then you see that the economics are more important for the STGR than the environment. But the environment's zero CO2 emission, no NOx, no SOx, these are extras we get for free. Next slide, please. Yeah, this was written about selecting a new technology. You have to take this in consideration. I have not gone in detail, but the blue things indicate what you all have to look at when you go to another technology. And yeah, I think that we are in very good shape when you look to all these conditions that are mentioned here. And the last red line is quite disturbing, but I didn't write it. It was just like this on internet. But take your time in a later phase to look at this, what is all important. But for us, this is not important because we comply with most of the criteria, and these problems are not for our technology. Next, please. This is what we want to do with coal-fired plants. At the left side is the Riverstone coal-fired plant, 5 years old, 730 megawatt now. And we want to convert it to with the nuclear islands, 7 times 100 megawatt. And the payback period, I calculated is within 5 years, you have your money back. And you earn a lot of money if you go from coal to uranium. So this was the start of the process to show the harbor of Rotterdam what can happen if we go from coal-fired to zero-emission plants. Next, please. Yeah, actually, this is the whole system. For the conversion of coal-fired plant, we only need the reactor and steam generator. These are very simple systems. They are not so complicated as the boiling water reactors or pressurized water reactors. It's just an open drum where you throw the pebbles in, and the pebbles go 6 times in their life of 3 years through the reactor. And it is automatically loaded and unloaded, so you don't have exposure of personnel to the reactor. If the reactor works fine, you never open it because you don't have to look for anything in it. And the steam generator is also quite simple. The compressor is at the top. So if you have to do maintenance, I think that is the only thing you have to repair or maintain is the compressor. I combined the nuclear island with skid-mounted. This reactor is 20 megawatt, and I combined it with 2 skid-mounted turbine generation sets from Siemens. You can buy them just like this. And if you put the reactor with two turbo generator sets, it becomes a very reliable system. I think it is even more reliable than the one that I just started in China, because there they have 2 reactors connected to 1 steam turbine and 1 generator. And we want 1 reactor combined to 2 skid-mounted units. So if something goes wrong with power generation, you still have 50% available. Most of the problems in a power plant are in the turbo generator set, not in the reactor. Next, please. Yeah. In 2007, I decided to only focus on absolute safe reactors. And how does an absolute safe reactor work? In the left top, you see what happens when you pull out 1 control rod out of the reactor and then shut down the cooling. So you have here an ATWAS and a LOCA simulated, and you see that the reactor stops. And after 30 minutes, you can try to start up the reactor again. The control room is very simple, as you see there. The big reactor now they have more panels, but this was enough to do the testing and preparing the big program in China for this reactor. At the right bottom, you see Dr. Aliki van Heek with her boss. She built for the Netherlands a module of how the reactor has to operate. Unfortunately, she had to go to the Atomic Energy Agency, and now this reactor is lying in my garage. If I can donate it to Indonesia, I'm most willing to do it. Okay, next slide, please. This is in 2008. Our Prime Minister went to the Tsinghua University, where he gave the lecture on energy systems for the future. And you see the test again there, and on the picture we have 2 of our professors from Delft standing there, Professor Tim van der Hagen and Professor Jan-Leen Kloosterman. Tim van der Hagen is the boss, and Jan-Leen Kloosterman is the fuel expert from the university. And they were in 2008 together with the Prime Minister in Indonesia, in China. Next, please. This is what Dr. Heinz Nabilek had published through Argagate. At the left side, you see only the uranium reactors using uranium-235 with uranium-238 as for the stability of the fuel. At the right side, you see that the STGR can use any fuel. That is what Mr. Nabilek convinced us about. And the two last options are very promising, but we can use many types of fuel in one same reactor. The reactor doesn't change. Okay, next slide. I just made a comparison of the pebble with the circular fuel assembly. It shows a little bit the safety of the different systems. The graphite will sublimate at 4,000 degrees Celsius, and the fuel assembly of the light water reactors, if you lose your fuel, you have a big problem. So it gives you an indication how that the safety considerations respected to heat are better with the pebble. The pebble can release its heat quite simple, and the fuel assembly, you need many systems to control the reactor. And that failed in Fukushima because they lost their emergency pumps, and then the damage started there. Next, please. Yeah, sorry, the safe at the top, it has to be a phi instead of an F. If you remove the boiler, if you only replace the boiler, you save about 80% of the investment. That is the rule of thumb in the coal-fired industry. And the nice thing is you don't have to close down the plant. While you're building the nuclear islands aside of this boiler, this can operate. And only for maybe a few weeks, you have to switch from coal-fired boiling to the steam, the nuclear island of the high-temperature gas-cooled reactor. So that is we save 20% of the investment, and we meet the goals from the COP26 in a very simple way. Next, please. Yeah, this is the nuclear. The same picture. I put the nuclear island to replace the boiler, and I show the advantages of the no CO2 emission, no SOx, no NOx, and since it's a high temperature gas cooled reactor, we want to use minimum cooling water. We want to use cooling water, but we want to make drinking water or pure water with it. And we also have the opportunity with the high temperature to go to high temperature hydrogen electrolysis. So these are advantages which come with this high temperature reactor, and where they are better than the current light water reactors. They operate at low pressure, and here we operate at high pressure. Okay, next, please. Yeah, this is I compared the solar and wind energy systems with our system, and this was the main picture which we showed at the World Hydrogen Energy Summit, why our system is the greenest one, and they gave us the prize for that. These are two compared systems which probably, if they don't have good systems, they will have to close down. These systems will not comply in 2050 with the COP26 conference because they still have a fossil fuel component, and we don't have that. Okay, next, please. Yeah, in India, they asked me to make a comparison of the cost. So this shows the cost. No, this was made for the Netherlands, where you see the cost of the several power generation systems compared to the STGR and the converted coal-fired plant. The last one is the coal-fired plant. And you see that the modern systems cannot compete with these two, the STGR and the coal to STGR. And also the hydrogen production, the cost is lower with our system. So this is what we are promoting now in the Netherlands. Look at the generation cost of the plant and look at the cost of hydrogen. Next, please. Yeah. In India, they asked me to compare the light water reactor, heavy water reactors with the STGR, and this is not a detailed comparison, but well, you can say in economics, all three are attractive. The cost of the light water reactors is, to my knowledge, 8 million per megawatt, and the STGR complete is 4.5 million per megawatt. Financing will be quite difficult for the light water reactors and advanced heavy water reactors, but I think for the STGR with the core damage frequency of 0, you will get financing easier. Deregulation in deregulation markets, the big plants have problems. The small plant can be placed anywhere and can compete. Liberalization also, same problem. And the power grids, the STGR, you just put it in the local grid. But for the big reactors, you will have to develop a high voltage grid. And the area, you will have to put the big reactors, you will have to put them at remote locations, while the STGR can be put in the local grid, so you can have more benefit of nuclear energy. The hydrogen part is that the STGR can go to both high pressure electrolysis and high temperature electrolysis, and that is an advantage. And yeah, the core damage frequency is for many countries a problem, but we don't have that problem because we don't have a core damage. And the last, the economics, the last line I don't see. Oh, sorry, I have it here with me. Exposure is low, the nuclear exposure during operation, but with the STGR is lower because you don't go in the fuel cycle. The fuel cycle is independent and you don't have a plant shutdown. So that is an advantage you have with the STGR. Next, please. Yes. People here in Holland wanted to see who is all involved in 10 Energy International and who is doing what. So we made this sketch. I started 10 Energy. We have a business development group. We have an advisory group. They are not working for us, but we are in good contact with them, and they have promised to help us. And if people from Indonesia wants to join or we work together, it will be most welcome, because the more people work on it, the better. Because as I mentioned, we are in a critical time in the world, and we have to try to convince people that nuclear energy is a good option, and we can convince them the best if we provide them with an absolute safe option. All the reactors are very fine, but what we can tell the people is that the high temperature gas cooled reactor is a safe reactor. I have this from, I went to, sorry, I'll show it later. Next, please. Yeah, to build nuclear power plants, you need a big consortium. And we have for power stations on land, we want RRI International from Germany to do the design, engineering, and project management on land. And we want Damen Shipyard to do the design, engineering, and operation of barge-mounted units. So we have two columns, one for STGR on land and one for STGR barge-mounted. We think that the barge-mounted reactors in the future will be the most important because they can directly produce water out of brackish water or seawater. Next, please. Yeah, so this is what we want to do in Rotterdam, and we want to convince the people, the Rotterdam Harbor, that they should go with us, because the other solution, which is now developed with hydrogen of sea wind energy, I think it will not be, it's not the right way to go. It will be expensive. And with this plant in Rotterdam, we can produce, sorry, yeah, this is the financial analysis of the plant in Rotterdam. So if we convert the plant, the Onyx plant, we can produce hydrogen for 48 cents per kg in with high pressure electrolysis, and 30 cents per kg with high temperature electrolysis. Next, please. These are some of the benefits I made for the Netherlands. That these are all the, because in the Netherlands they have plans to build 2 large EPR reactors, and those will cost 25 billion euros. And if we convert the 4 coal-fired plants in the Netherlands, it will cost 8 billion. And the 4 coal-fired plants will produce more power than the 2 new EPR reactors from France. And we have no losses, because a power plant is not a plant on its own. It is a whole society is around it. And if the plant can be converted, everything will stay the same. The economy will be the same. So you save a lot of the existing social infrastructure also, aside of the power infrastructure. And I put here that the conversion of the Onyx power plant will be breaking news, because till today we are the only one who is proposing this. I have not seen anybody else who has come up with the idea to convert coal-fired plants. So if we could do this, it will be news for the world. Next, please. Yeah, these are the 4 plants which we can convert, and we can save a lot of money for the Netherlands. And as I mentioned, Rotterdam is a huge energy eater. We can start in Rotterdam. We can demonstrate all the advantages of power conversion from nuclear to heat and so on in Rotterdam. We also have the large greenhouse complex, Westland. They are also supporting our idea, because they want a lot of power and heat from this power plant. Okay, yeah, the last thing is very important. The greenhouses, we want to support them with electricity and also produce CO2 for them, because we have to go to 400 ppm, maximum 4 ppm CO2 in the atmosphere, but in the greenhouses it is 2000 to 4000 ppm to get the best conditions in the greenhouse. So these things we should not forget when we look at solutions. Next, please. Yeah, so we want to stop burning coal, and we want to go to clean coal. That's why I put this picture. So we go from $250 a ton to $250,000 a ton, because 1 ton of the pebbles will cost $250,000. So you see that a huge added value can come in the coal economy in Indonesia. And the converted plant can do more things than the coal plant. The coal plant at this moment only provides electricity, and we can provide steam, heat, and gamma rays radiation sources. And because of the steam, we can do electricity, hydrogen, and ship propulsion. Ship propulsion I will show later. But one of the important things might be that we have to do research on how to use gamma radiation to clean our spaces where we live, because Corona has shown us that we need clean air to survive in closed spaces. And maybe we can use the used pebbles as gamma source for cleaning the air. Next, please. Yeah, you see all the components. So the coal industry will have a revival to a better and clean industry, whereby all these components have to be made. The pebbles, the structure components, the wall of the reactor, in the inner wall of the reactor, all these are high added value products out of coal. Next, please. Yeah, the global green revolution starts. Next, please. The next. I want to show you all the. Sometimes people say, yeah, it is not proven technology, but this is for me proven technology, because the AVR started from 1966 till 1988. The THCR, the thorium high temperature reactor, I also visited this plant. It was a very nice plant. Well, unfortunately, it was closed after Chernobyl. Then the Chinese came with the ICR-10, and we are proposing STGR-20. The Chinese took the HCR PM200, which is actually the German HCR module reactor. The Germans helped them to develop that. And new developments are that America is copying the German design as a XE100 USA, and UK is doing now the same. They have joined the UK has joined USA to do the same, and the Chinese even are planning a 600 megawatt high temperature reactor, whereby they will put 6 steam nuclear islands in one reactor building. That is the right bottom picture. So for this all is for me sufficient information to say this is a proven technology. We don't have to invent the wheel. We just use what is invented already, since the Germans made it with the HTR module reactor. And let's start as soon as possible, as quick as possible. Next, please. Yeah, with the green revolution comes a lot more. Not only everybody's talking about green hydrogen, but first we need a global Marshall Plan to convert the existing coal-fired plants to green plants, and then we can also at the same time build new plants. But the conversion of the coal-fired plant is one step, but these plants these small STGR reactors can work very fine with wind parks. There is a thesis on from Professor Verkooyen and Dr. Brian Boer. I can send that if people need it. How you can make this small HTRs work with wind parks to create stable, reliable power. Same for solar parks. But also the cement industry, the steel industry, the ammonia industry, and the aluminum industry can benefit of this new technology. I worked in the aluminum industry, so I have developed a plan to produce aluminum for $1,000 a ton. And if somebody wants that report, I can forward it also. But all these industries can go green now if you have hydrogen. But the hydrogen must be cheap, otherwise it doesn't make sense. Next, please. I here put some industries together with coal and pebbles, how to see what will happen in the Netherlands when we want to go to Dutch 02 industry. All these industries can benefit of the STGR reactor with zero emission, with hydrogen, and with cheap electricity. Next, please. Yeah, this is what is happening at the moment in the Netherlands. They want to have wind power from sea. And as some tables showed before already, wind power from sea will be the most expensive wind energy. And if you convert it to hydrogen, you will have energy losses at the electrolyzer, heat losses at the electrolyzer. And then I think that the GasUnie is behind this idea, because they want to use the existing gas, natural gas network to bring the LNG, the hydrogen to Rotterdam. And the next page shows what I think is a better solution, because this will be expensive and complex. Next, please. Yes, I want this, the red framed solution is where I want to convert the 700 megawatt coal-fired plant and replace the coal boilers with the nuclear island, and you get immediately at the spot, you get all the electricity, hydrogen, you can help the data centers, you produce dam and water, and you can help also the greenhouse farming in the Westland. So this is the proposal we are showing to Rotterdam, that this should be looked at. Next, please.
Sorry.
Yeah, here you have a big picture of the two systems that we compare. You have the coal-fired plant at the left side, and at the right side you have the converted plant as we have proposed it and have registered it also. Please, next. Yeah, this is the how you can combine our technology with the wind parks and hydrogen. So it could this can be done very simple. This is not complicated to do this. Here we use the high pressure electrolyzers from ITM. Next, please. For solar, the same. You can do the same. Instead of wind, you can support the solar systems also to become reliable power. Next, please. We can use the STGR also to produce low-cost ammonia, and the technology here is called PNO-Sierra, has been developed by the Leuven University in Belgium to make small green ammonia units. I've put the website there where you can see the information on this technology. So this is one option which we could look at. The next slide shows something more, I think. Yes, we have two problems in the Netherlands. We have a CO2 problem, and we have an ammonia problem because of too much cattle, cows, pigs, and chicken manure. It's a big problem. But if the cattle is making the ammonia for us already, we'll make savings in the process, in the Haber-Bosch process. And if we use CO2 out of the atmosphere, we make in a very nice way a lot of fertilizer, which will be needed very much to feed 9.8 billion people in 2050. So I don't know why these two things are overlooked in the government policy, but these are two simple ways to solve the ammonia problem and to solve the CO2 problem, because we can make something very good with it. Next, please. This is a big picture of the Belgium invention. But as I told you, I think the ammonia can also be made in collaboration with the farmers, that you remove the water, the ammonia from the manure, and those technologies have been developed in the Netherlands. So that is not rocket science; it is known already. Okay, next slide. Yeah, this is green aluminum. I worked for Alcoa, aluminum company of America and Suriname. And my feeling is that if we put the STGR on the bauxite deposits, you can make aluminum for $1,000 a ton, because you eliminate the transportation. Bauxite transportation is terrible, especially in the rainy seasons. And also the transportation of alumina is a headache. So if you put the STGR with the refinery and the smelter on the bauxite deposit, you can produce aluminum for $1,000 a ton. I have a report on that, so if you want that, I can send it to you. Next, please. This is how we could help the cement industry also to reduce the use of oil in the kiln to heat up the the sand or the cement, but I have not gone in detail with this. This is just I show that it is possible that we can replace oil burning in a kiln of the cement industry. The next one is the steel industry. Yeah, the steel industry, this design at the bottom, the hydrogen-based route to steel, is from the European Union. They have a group that developed this, and we can provide the hydrogen for this technology. We have also the next slide shows that we are also working on new technologies, and this could be ideal for places like Bataan to help us to look at this application. The new applications are the green ship propulsion with thorium as fuel, large-scale drinking water production, because we will need a lot of water in the world. Use pebbles for heat and gamma ray sources, for agriculture, healthcare, food preservation, and to combat diseases. And especially for the ship propulsion, because we are working with a shipyard in Indonesia to see if we can do that there. Next slide, please. You could use the STGR to, instead of the big diesel engines, which are diesel and bunker C fuel engines, which are polluting the world in a terrible way. They say that 16 of the big ships pollute the world more than all the cars in the world. You can see that publication on internet. And if we do this, we have a zero emission system. And if we can build this technology at Kendal in a new shipyard, it would be ideal. And we have talked with Daman shipyard here to do it. And also in the north, we have Kono ship that is looking at hydrogen propulsion. So we can combine steam generation propulsion with zero emission or hydrogen propulsion. So both things are looked at in the Netherlands, and we could combine that in a shipyard on Java. Next slide, please. These are the companies who are working in the Netherlands on high temperature electrolyzers. I put it here because everybody is talking about hydrogen. So I asked the harbor of Rotterdam, please tell these people that we also have a good solution. So maybe our name sooner or later will come here in the list also, but at this moment, not yet. Next slide, please. This is how we want to see the future in the Netherlands, in Rotterdam, and maybe this can start in Indonesia before Rotterdam. For us, it is the sooner the better, and it doesn't make where we start. This is the plant that is converted. In the beginning, you have the coal-fired version of it, and here you see what can happen if we get the opportunities from the Dutch government. The next slide is the last slide with some of the companies we work with. Yeah, we have an MOU with ArgeKT. They have promised to help us with technology and know-how. RRI is the preferred contractor for design, engineering, and project management, but we can combine it with companies in Indonesia. ENSA is the Spanish manufacturer of nuclear plants, so they want to build the plant. Daman wants to build the barge-mounted plants. And we have also some environmental companies working with us. Groasis is focused on how to stop deserts, how to stop the deserts. They have a very nice technology. And in India, we have also a company that is in biofuels. And in Suriname, we are working with the company Rope North. They want to start sustainable forestry in Suriname. That is all I wanted to show you from our side. And if you have questions, please let me know.
Yeah, thank you very much, Dr. Raymond. It's very interesting to learn many things from you about your idea to change the coal power plant, the Onyx into STGR. Well, the STGR is the abbreviation of small thorium.
Simple or small thorium gas cooled reactor.
Okay, because
it's a simple reactor.
I look for that abbreviation. Now I know this is simple or small thorium gas reactor. So before I give to the floor to ask you, would you please to give us the background of Netherlands? I think Netherlands have one nuclear power plant, the Borsele, isn't it? That the small 482 megawatt. And my question is, with this situation, the Russian-Ukraine crisis, and Russian stop the gas supply to Europe, including to Netherlands, does the Netherlands want to change their policy, for example, to increase or to accelerate to build the nuclear power, or maybe they want to reoperate the coal power plant? Please give us the explanation of your country.
Well, in the conclusion somewhere, I have mentioned that there was a group called the Western society. You cannot trust it because they changed the rules how it fits them. Because on the COP conference, all these countries were saying we have to close the coal-fired plants. We have in Netherlands an environmental group, Urgenda, who started a lawsuit against the government to close the plants. And they won the lawsuit. And now that same Urgenda says, well, seeing the situation, we have no problem that the coal-fired plants continue running. Then what type of environmental group are you? You are a lobby group for big business. So all the coal-fired plants have now the permission to go to full power operation again in Netherlands. And that is not fair to the poor and developing countries, because on the COP26 conference, people were crying there that they were losing their islands. And these countries made the big promises to help there, and now they are coming back on their promises. So I did write to Boris Johnson and Mr. Alok Sharma that what is happening? But you don't get an answer back. So in the Netherlands, fortunately, I think very soon we will have the decision about the coal-fired plants. As I told you, I'm against the big coal-fired plants because I think with the small coal-fired plants, small reactors we will promote, we can bring also the more technologies to the country than only big plants that only can produce electricity for Netherlands. If we put 2 big power plants in the south in Zealand, the climate around the plant probably will become tropical. So we can go on summer in Netherlands because if you generate 2 times 1600 megawatt electricity, you generate about 5,000 megawatt heat there in the environment. And you cannot do high pressure electrolysis because the temperature is too low. You cannot do the gamma radiation because one of the nice things of the pebble bed reactor is nobody touches the pebble from the moment it goes in the reactor. And even if you go and use it for heat purposes afterwards, or you use it for gamma radiation, nobody has to touch the pebble. You can do that all automatic. So these advantages are better for us in Netherlands than the big reactors. And we have no know-how to build them.
Why I ask you about that, because as far as I know, Germany want to reoperate the coal power plant again rather than nuclear power. Because of the crisis.
Recently, it is published that Germany will open its biggest nuclear plant again.
Oh, really? Yeah, that's good news. Okay, thank you.
Well, I can send you that information, but it is good news, but it is not fair to the developing and poor countries. The rich West is doing everything for its own, not for the rest of the world. Okay. That is the problem.
Okay. Is there anyone want to ask directly to Dr. Raymond? Maybe Bugeni or Pak Yaryanto want to? Well, please, Bugeni.
Okay. Thank you so much. Thank you very much, Dr. Raymond. Your explanation is very, very interesting one. Thank you.
Thank you.
And then
Thank
I
you.
want to ask you a few questions regarding of your explanation about the technological and then regulation or something like that. First one, I want to ask you, what is the highest temperature that can be produced from STGR that you described? And the second one is, I'm very happy to hear your proposal that this technology can be coupled, yeah, with the existing coal power plant. Yeah, this is very interesting one because Indonesia also has a very ambitious roadmap to be to have a high commitment on zero net emission carbon. So your proposal is very interesting one. So I want to ask you, based on your experience, how to regulate the idea of this replacement or the combination with the STGR and the coal power plant. This is very interesting one. And then it will be a good lesson learned for our regulator, of course. And the third one, I want to ask you how is the status of the fuel licensing? Yeah. And the last one, I want to ask you if we can work together, yeah, on develop the specific design for Indonesia, how to maintain the fuel supply chains. Okay, that's 5 questions, Pak Jarod.
Okay, please, Dr. Raymond.
Yeah. Okay, the first question is the high temperature, the exit temperature of the reactor is 750 degrees Celsius, about that. But yeah, you have technologies where you can go even higher. By accident, I have this from, I was in 2012 in Japan on the HCR conference, and I got this from the HTTR of Japan. This is the only plant that had no problems with Fukushima. That is what I want to say. I just had it here. So this reactor, the HTTR, can go even higher, I think, but let's keep it on 750 because the higher you go with the temperature, the more attention you'll have to pay on the fuel, on the metals that you use. That's why this STDR is a very smart German design, because when I talked with them, I said, you go to so high temperature and you say you can do it with the present light water reactor vessels. They said, yes. And I asked, why? Because they are designed for 300 degrees. They say, well, the discharge heat of the steam generator goes at the outer side of the graphite in the vessel, and the heat is only in the inner side. So the 750 is in the inner core, between in the graphite containment, but the outside vessel only sees 300 degrees because that is the temperature on which the helium comes back from the steam generator. The conversion of the coal-fired plant, I think it can be done in 3 years, because we built the Dodoat GKN coal light water reactor in 3 years here in 1965. So if in 1965 we could build the whole plant in 3 years, then conversion of a coal-fired plant, where we don't touch the coal-fired plant, we just build the steam generator set, nuclear island, aside of the boiler, and then at the end you disconnect steam and connect steam, and we can show that it will be more economical to convert the plant running on thorium or uranium than using coal, because coal will become very expensive. Today, I think it's already $400 a ton. So in my calculation, you can see also, there is one sheet where you see the price difference in generation cost between a coal-fired plant and the STGR, and the generation cost for a big plant compared to the one in Rotterdam we want to change. That is all shown there. So changing it for coal is not only for the environment, but it will be more economical. And as I told you, the coal industry will become very rich in Indonesia. The third question was replacement. You had something on the replacement. Can you?
Could you repeat again, Bugeni, your question?
I think the third question related with the license of the fuel, the status, recent status.
Okay. Well, the licensing of the fuel and the regulation is, I think you should ask the regulatory body if you can use the coal-fired plant license to convert it to nuclear island, because the coal-fired emissions are much higher in nuclear, and they produce more nuclear energy in the environment than a clean nuclear plant. The calculations show that the high temperature reactor will release not so much radioactivity in the environment as the coal-fired plant is doing today. So maybe the regulator says, okay, I will accept it, but you will have to, I think you will have to convince the regulator that we need an urgent solution for the world, and that this is a safe reactor. You don't have to worry about the safety. And it also produces less radioactive release compared to coal-fired plants. And there is also a very good technical tech doc from IAEA, tech doc 1366, on high temperature gas cooled reactor. I can send it to you if you want it.
Okay.
1366. I will send it to Mr. Sayaf and to ask it to forward it.
Yeah,
there, the IAEA also specially asked the regulator, please look in a different way to this reactor, because it is not a defense in depth concept. It is a safe reactor. So I feel that a good regulator must help you, especially in the situation as we are now in the world, that we can come with something very quick. And if we can use this on the coal-fired boiler plants in Indonesia, you will be the first in the world. Nobody has this so far, and it's not new technology. It is very it is conventional technology that will show there that we can do this. It is not nuclear technology. Connecting a new plant on the steam side to an existing power generation set is not nuclear technology, simple technology. So that's why this must be successful. And if your president wants to say to the world, I will save the world, I think he can do it this way. and the fuel licensing, I think we have to work on that. I know that at ECN here in Holland, we have done all the testing of the fuel even for China, for South Africa. So we can approach ECN to work with them on the fuel that you want in Indonesia, but maybe you can do it also there. So ECN has done a lot of fuel testing for most of the high temperature reactors. I even had a test module from Jülich, because the sad story in Jülich is that at a certain moment the whole institute there was closed. So they had a very big test unit for pebbles, and they asked me if I wanted to take it with me, because otherwise it would go to the destruction. So we removed it, and at that time I wanted to work with some Belgian people, so we brought it to Belgium. I don't know if it is still there, but I can find out. It would be something unique and historical if we can find it and put it somewhere where people can see what the Germans have done in the past. And the fuel supply chain, I think the best what we can do is that we start with the fuel production in Indonesia itself, because you can buy in 2 years, Nucam Germany can provide the whole plant, and you can produce the fuel in Indonesia. So you have your cheap graphite, you have your power production plant. You will need to have some driver fuel for the kernels, but I think everything can be done in Indonesia. That's why it is a very nice solution that you are not dependent of France or USA or Japan. You do everything in Indonesia. And I think with the people I know in Germany, the Argekate people will be very happy to help you with that. You know Dr. Nabi like yourself. Yeah. So, you know, they are very nice people, and I work very nice with them. And I hope that we can use much of their knowledge to bring it to Indonesia. Okay.
And thank you so much, Dr. Raymond.
Okay. Thank you
I will
very
send you
much.
that report 1366.
Okay.
Okay.
Okay. Okay, Bu Geni, is there anybody you want to? Pak Yaryanto, please.
Okay, thank you, Pak Jarod, for the opportunity. Thank you, Mr. Raymond, for your excellent presentations. Yeah, I remember that when we have the project for the RDE reactor, the experimental power reactor in Indonesia, when Professor Jarod as chairman of Badan, and I have the responsible to running the project at the times. I think this technology is also introduced using the STGR, but the small 10 megawatts. But Bu Geni also have developing the design, and also we already have the site permit at the time.
That is great. If you have the site permit, you are in great.
Yes, because of
we can start tomorrow.
For the small. So
we can start tomorrow.
We also have thinking the same as you, that the kind of nuclear power plant STGR is very makes sense with the Indonesia country, that we have frequency of earthquake. So because this is very safe, so it is a good choice for the STGR. So we have also the vision to develop the STGR at the time, because many small power plant and in the small islands, but maybe in the future need to be replaced by this kind of STGR. So Indonesia also have the biggest production of coal. So in line with the proposal of net zero emission. So I think the power plant using the coal will be replaced by new and renewable energy. So I think this is the big opportunity for the nuclear power plants. I have a question to you regarding the technology development for the graphite. Graphite is need maybe coal, as raw material. Indonesia have many coal that maybe in the future will not be used. So I think it will be converted to the graphite production. And also if the STGR will be used widely in the world, I think we have the opportunity to export also the graphite. But the problem is the technology, I think, is very sophisticated to get to obtain the graphite until the nuclear grid, because like China also still dependent with the Japanese product of graphite. So I think this is maybe you have any possibility to develop the graphite also for to support the nuclear fuel of people fuel. Also, I remember then you say that the Nukem will maybe will happy if help us. So at that time also we have cooperation with the Nukem, with the small what is prototype, prototype of these people, but for the kernel, kernel production. And I think this is a good technology, and we know, but for the TRISO we have not yet for the technology. I think we have questions about that. The second question is about the consumption of uranium and thorium because I think this is if you use the thorium, should be used uranium also for combine, yeah. Oh, combine, but yeah, mix, yeah. How many percent the enrichment of the uranium, and how about the ratio of uranium and thorium? Because I have read one of the publication that uranium still dominant than the thorium for using, and but this is not for the STGR, but the other technology for molten salt reactor. So how about in the STGR, your proposal for the uranium and thorium ratio? Okay, thank you very much. Yeah.
Okay, I can send you the information of Dr. Heinz Nabilek about the fuels. So I will send, because with fuel questions, we prefer to talk with the specialist himself. And Dr. Heinz Nabilek is always happy to help us. So I will send you what he has sent, what I have from him. And if you have further questions, let me know. Then I can start from there.
Okay. Well, Dr. Raymond, I think the first question of Pak Yarianto is about the technology to make the graphite, because the China is still import from Japan on that graphite. What do you think about that?
Well, I had not gone far in detail on that on the moment, because when I was in Japan, I saw that Japan is very far with the graphite production. So I felt that that could be covered there, but also the reactors in UK have all the time run on the gas-cooled reactors. We're all using graphite. So we could also look in the UK for technology. And here in the Netherlands, we have a company in the north, ESD, who is making graphite on specification of customers. So I think the graphite question can be solved quickly. I think that is not a big problem. But now I have heard this question, I will also contact Dr. Heinz Nabilek, and I will contact the company in the north. But I need to know a little more. But I didn't raise so much problems on that, because you have China, you have Japan, you have UK, and we have also in the Netherlands a company that makes the graphite. So give me some time to answer this.
Okay, thank you. Pak Yarianto, do you have still any other comments?
No.
Dr. Raymond, please, if you want to discuss more detail, maybe these two persons, Ms. Geni and Pak Yarianto, is the main player of our STGR technology in Indonesia. Okay. Maybe. So
I'm very glad that you all are there, because in other countries, I go to India and people there, they don't know what the high-temperature gas-cooled reactor is.
Yeah. So, and he's already have the site. The site permit is already received from the regulatory agency.
You know what it is. For you, nobody has to convince you anymore. But in India, I have to convince all the people.
Okay, thank you. Masih ada pertanyaan Pak Yan?
Cukup Pak.
Ya, terima kasih.
Yang lain
Pak. Dr. Raymond, well, for Indonesian government, we are starting to stop to construct the the coal power plant in 2025. But the questions is what kind of power plant to replace that coal power plant? And if nuclear is one option, the problem is about the long constructions or long time to build. What do you think about your technology?
Well, that is the nice thing of the pebble bed reactors. They are modular, especially the STGR can be manufactured in a workshop, because these are small reactors. The bigger one, the 100 megawatt units, you will have to can also be manufactured in a workshop and brought to the site. And I think we can build these things. The new reactors, if the components are available, you can build such a big reactor in 3 years, the big ones. the small ones probably in 2 years, because the lead time is the reactor vessel. So the rule of thumb with talking with people, they say the small one, you could build them in 2 years. And after that, of course, you can build one every month, you deliver one. But the first one will take about 2 years, the small ones, and the big ones can be built in 3 years.
Mm-hmm. Okay. Yeah.
I know Professor Xu from China, from who he was responsible for the nuclear island for the HCRPM now. So I can ask him also for information if it's needed. He's a good friend of mine.
Okay. Well, the second one that I want to give you a bit of comment, it seems that Indonesia doesn't want to be the first one. For example, the foreign companies coming and I want to build my technology in Indonesia. It seems that some foreign company changed their strategy that, oh, it is better, I want to design of the technology made in Indonesia. How about, what do you think about that?
If you ask me, I think buy the first 2-3 reactors, and at the same time you make your own drawings and concepts. And so I would not wait. I would start now. You can buy the things. You can buy them in Spain. You can buy them in China, and start as quick as possible. And in the meantime, you build your own industry. I think everything can be built in Indonesia, and we should do that also, because we cannot trust the rich countries, because they change the scenario to fit to their own interests, not to the world. You know, the thing that coal-fired plants can start now again. Germany was against nuclear energy, starts nuclear power plants again. Very soon, the same thing will probably happen in France, because they have some problems with the light water reactors, maintenance problems. And if you get a cold winter, the whole system in Europe will come in problems. And yeah, I feel that this technology can be 100% made in Indonesia, and I think I would love to participate in that with you.
Okay. Yeah.
Where we can help, we'll do that, definitely.
Yeah. Thank you. I think there is a question from my friend, I think, Pak Purba. Do you have any question directly you want to ask to Dr. Raymond? If you want to ask directly. There is one question from Mr. Purba Robert Sianipar. Dear Dr. Raymond, I am interested to read the report of using green technology to produce aluminum ingot. Do all of the green energy that you explained based on the use of nuclear or thorium technology? And he wants to know in detail and maybe want to communicate with you by email. So his questions, do all of the green energy that you explained based on the use of nuclear or thorium fuel technology? This is the question of Mr. Purba, please.
Yeah, I would love to work with him on the aluminum, because I have worked for quite some time in the aluminum industry. And yes, I have a report on that. I can send, if I have his email address, I can send him right away so that he can start working on that.
Okay.
But that would be also a nice place to come with new nuclear and new STGR, small ones, because then you give the plant, you give the heat for the fire process, and you take the electricity for the Hall-Héroult aluminum process. That's the nice thing of this reactor. You can get both steam and electricity from the plant at the site, and that's why it becomes $1,000 a ton.
Okay, thank you. There's one question from Mr. Suryantoro, the former deputy chairman of Batan. Please, Pak Suryantoro.
Thank you, Professor Jarod, for the time, and also thank you for Mr. Raymond for your very excellent presentation in afternoon in Indonesia. Okay, I have one question is about the technology, the new technology of the nuclear power plant. In Indonesia, there is two kind of the NPP technology supporters. That is, the first one is about the STGR technology. The second one is about the small, what we call is molten salt reactor. I'm wrong anyway. About the molten salt reactor, MSR. This kind of technology. My question is, which one will be ready in the near future? Because we know that we work in the research institution, so we have to like to know about the best or no. Then they will be ready about the readiness level of the technology. Which one will be the first or can be implemented as a commercial scale in Indonesia? Thank you very much.
Okay. Well, it is quite simple because the same question I got from Turkey when I was talking with the Turkish specialist. Professor there asked, why should we go to the STGR? We are working on this molten salt reactor technology. I said, well, I'm not against the molten salt reactor technology. It looks very nice. Mr. Weinberg had it also in the 1950s. But at this moment, we don't have any proven reactor anywhere in the world. So we will have to wait to see if we can make those reactors the way they say it. And the STGR, you can start tomorrow. You can order the equipment anywhere you want. And we have proven in the world, the STGR has been proven in the AVR. It has been proven now in the ACR-10 in China, and now in the ACR PM200. So it is proven technology. You compare with a design, and that is not realistic, because the design will have to be tested, have to be approved by the regulatory authority. Then you can start with the manufacturing system. So yes, any nuclear system that comes, we should support it. I also support the molten salt reactor, but we have to see where the technology is. And we are in urgent need for a solution now. Otherwise, I'm afraid that we will go to the Third World War. And with the STGR, probably we can stop. But it must be in mass production. So if the STGR would come in Indonesia, it will be not only for Indonesia, it will be for the whole world. That is what we have to think about. It will be a huge project that can start in Indonesia. It could start in India. It could start in South Africa, because I'm working on more places. But the conditions for Indonesia are, in my view, the best. Okay. So let's hope that we can start there.
I think the answer is very clear, Pak Suryanto.
Thank you, Mr. Raymond and Dr. Thank you very much.
Yeah. Please, Pak Sarwi, if you have any questions to Dr. Raymond.
Yes, a quick question, Pak Raymond. You mentioned Damen, a German company.
Yes.
Is it correct that Damen is now building or developing a kind of a barge-mounted STGR power generation?
No, they will decide. They say if you have people who want the power plant, we can put it for you on a barge. Damen is building modular barges. They are the biggest in the world, and we were thinking of 100 megawatt power plants on big barges with the size of 36-meter width and 150 meter long. So you can put 5 20 megawatt units on such a barge. I have a schematic of it. I can send it also. And Damen has an MOU with us. They want to be the first to do it. And we mentioned that we want to start in Indonesia, and they are also willing to work with us in Indonesia.
I see.
Yeah.
Yeah.
You also mentioned something about the STGR technology is ideal solution for peaker for the peaking replacement or something like that. Is that correct?
for the replacement for the coal-fired plant is ideal because you convert the coal-fired plant to a green plant. It will becomes a totally green plant, no emissions anymore.
I see. Thank you.
Okay. Is there any still question, Pak Sarvi? No?
That's I think enough for me.
Okay. Thank you very much, Pak Sarvi. I think I would like to ask again Dr. Purba to give the questions, please. Apa kabar, Pak Purba?
Baik, Pak Jarod. Thank you, Mr. Raymond. It is interesting sharing that you give me. Actually, I'm now assisting one of the foreign investors in producing aluminum in Bintan. And we plan to have at least minimum 2,850 megawatt of electricity to produce the 1 million ton of aluminum ingot per year.
Yes. Okay.
And then now Indonesia implement the policy of using renewable energy. Yeah, it's like Indonesia trying to abandon the use of coal energy. Yeah, though the end destination supposedly net zero emission. Yeah, because Indonesia has a plenty of coal. Yeah, and the coal is the most economic power plant based for any type of production. So that's why I'm interested that when you mentioned the production, is it the production cost $1,000 US per ton?
$1,000 per ton, yes.
Yeah, is it included the cost of the material? Is only the process?
If you have the bauxite, I have put the process for the bauxite. I put $25 a ton because you are on the deposit. You don't have to transport it. You bring it directly in the process.
Yes.
I will send you the presentations, and then we can discuss it further because aluminum will be very important very soon. So if you can make it for $1,000 a ton, you will be the best-selling company in the world.
Of course, that's why I'm interested. And please, share with me all this material. But all those energy that you mentioned is based on the thorium, is it? Or nuclear, something that Indonesia may not be able to implement right now, I guess.
You can use uranium or thorium. Uranium or thorium, you can use both. This reactor has the iron,
and then maybe it's worth
combine fuels.
Yeah, for Pak Jarod and his colleagues to really use the new law of the new energy and renewable energy that has the nuclear implementation inside to be able to produce this, because that will make our industry, Indonesian industry, competitive, as you mentioned also in your presentation. Thank you, Mr. Raymond. Yeah, I'm looking forward to receiving from you.
And I hope to work soon with you.
Okay, I already sent it to your chat directly, my email, but maybe Pak Jarod could also help.
I will deliver it to Dr. Raymond. Okay, terima kasih.
Terima kasih. Thank you, Pak. Thank you.
Thank you. Terima kasih.
Okay.
Yeah. There are a lot of questions for you, but I will choose one. This is very, very common question from Indonesian people. Indonesia is a country, archipelago country, many islands and many earthquakes. Why do you think it is very safe to build the nuclear power plant or STGR in Indonesia? This is very common questions among us. Please, if you have any.
Well, in my presentation, you have seen a graph about the absolute safe reactor. You know, what hurt me the most was seeing the hydrogen explosion on the Fukushima 1 reactor. Because with that, we make people do not trust us anymore. People don't believe nuclear scientists because they say, well, it is safe, but then something like this happened. We should not give the society reactors that people can do this again, because the moment a nuclear reactor comes in problems, the whole world opinion is against nuclear energy. That is why we have to select absolute safe technology. And this technology, even the Atomic Energy Agency will tell you, this is absolute safe. We have to give the people absolute safe reactors, and it can be demonstrated. As Professor Tim van der Hagen mentioned in the slide, he said, anyone who wants to go to see how the safe reactor works can go to China. They show it to everybody. So that is good news, because I was also there in 2004. And my reaction was, when I came out of that control room, is why is this information not told to the people that there are also safe reactors? So I hope that this explains it. And if somebody does not believe it, I think the best thing is that when the first reactor starts in Indonesia, then you demonstrate the accidents from Chernobyl and Harrisburg and Fukushima on the reactor, so that the people can see that the reactor, nothing happens with the reactor. While so big accidents could happen with nuclear energy, you have a technology that it cannot happen there. And this is not in books, it is reality. I was standing in the control room and nothing happened with me. I'm sitting here today.
Yeah.
And they tested the two most serious accidents on the reactor when I was there. And nothing happened.
Yeah, I think I agree with you. Statistically, the safest technology, the safest power plant in the world is the nuclear power plant.
And for Indonesia, at many islands, the small STGR is the best solution, because you can put it on a barge anywhere and it will give you water, electricity, hydrogen, and gamma radiation. These are very important things in the future. How do we feed the nation? And gamma radiation is very important to secure quality of food.
Yeah.
High quality water, high quality food, and clean air. That is what you have to give any nation.
Yeah. Okay. And I think about the earthquakes, because we have many islands that minimum possibility of earthquakes, like Kalimantan, Borneo, or maybe part of Sumatra. So we can first maybe to build over there, because it's very stable, almost no earthquakes. There are many places, I think. Then our questions, my question is, as a researchers, how about the future collaborations? Do you think we have a possibility doing the research together to implement or to redesign your technology in Indonesia, between your company, TEN Energy, and our institute or our agencies? What do you think about that?
Of course, I would love to work together with you people, because I have been in Bataan. It was very nice working with the people there. I was only one day there, but I really liked the harmony and the friendliness. The STGR technology is out of development, but the new things we want to do, yes, we can do that together, because there are some technologies which can make the STGR much better. One is the MTech. Alkali metal thermal electrical conversion, where you don't need mechanical equipment to produce electricity, but then you have to take the high temperature and convert it directly to electricity. That is possible, and that we could do in Indonesia. The gamma radiation is just mentioned now. Even Professor Klosterman said the pebbles are ideal for gamma radiation, but we have to do it. We can use the gamma radiation to solve many diseases, like the mosquito diseases, bilharzia, all those things. You can use low dose of radiation to stop the egg to develop, and then you solve the diseases which are deadly in Bangladesh, India, Africa. We have to look at ways, maybe we can use gamma radiation also to pure our air before we send it in closed spaces, because we had Corona, but nobody is thinking what will happen if Corona comes again. We have been thinking of how do we treat air, that people get clean air in big spaces. All these technologies we could do in Indonesia and more.
Okay.
Yeah.
Well, thank you. There are last question. There is one question from Mr. Ismail Ibrahim about the STGR. Is there any radioactive waste generated from STGR? How to manage that kind of waste, if any, please?
Well, there is a document from the Atomic Energy Agency. If we go to the thorium fuel cycle, that is why we promote the thorium fuel cycle. The thorium fuel cycle will produce minimum radioactive waste. So if you have minimal radioactive waste, and sooner or later the molten salt reactor comes online, then we can treat that minimum radioactivation in a proper way so that no nuclear waste exists anymore. So I see the working of the STGR with the molten salt reactor as a combination. The reactor, the STGRs for economic power generation, and the molten salt reactor to clean up the mess we create with nuclear energy. So there is no problem. The solution with nuclear waste was solved already. I worked at General Electric in the 1990s, and the General Electric also has a molten salt reactor, the PRISM. It is maybe different from the designs that are made now, but the PRISM could also be used to get rid of radioactive waste. So radioactive waste is more a hype to scare people than that it is really a problem, in my view.
Okay, thank you very much, Dr. Raymond. I think your explanation, your presentation is very impressive one. Hopefully we can work together or maybe have a collaboration on the research and development. But
yes.
Anyway, before we close the webinar, if you have any closing remarks for the audience, please.
Well, this is my request, and I put the same request also to the people I met in India. If you can convince your president that Indonesia can solve the global problem with energy and food, and that the world gives, the G7 gives Indonesia the chance to prove it. That would be my simple request, because if we can give the world energy, water, and food, we will have no problems, no war, no tension, and this technology can be, as I showed you, be realized in India and Indonesia at the moment the best. In other countries, of course, you can do it also, but then you have the lack maybe of manpower, or you have the lack of the fuel, and those things are covered very well in Indonesia and in India. So my request is, if it's possible, to tell you, President, Indonesia can solve the problem for energy and food and water for the world.
Okay.
If you could do that, I would be very happy.
Thank you very much, Dr. Raymond Balad Singh. It's very interesting, very impressive, your presentation. I think it's very valuable to us. I will deliver, or maybe I want to convince everybody in Indonesia, the nuclear technology is very promising for Indonesian people and everywhere in the world, because we have facing the same problems, the climate change. And we are now suffering the climate change directly, because June always on the dry seasons, but now we are in the rainy seasons. Very, very, very unique situation in Indonesia. Anyway, thank you very much, and I hope I can still communicate with you. I will communicate also with Mr. Sayapse. Thank you very much.
Okay, may I? Yeah, you have to do anything, because you have to solve this problem also for your own country, because your capital is going underwater.
Yes. Okay.
You have to build a new capital because of the water problem. So I think that is one extra reason that Indonesia has to take the lead. And I will be most happy, and our team will be most happy to work with you. And you know that the Germans also always, as I know the Germans, they like to work with the Indonesians. So I think we can have a very good cooperation together.
Okay.
Okay.
Okay. Thank you very much, Dr.
Okay.
Yeah.
Thank you.
Yeah.
Okay.
Yeah. Terima kasih Bapak Ibu sekalian sudah mendengarkan dan menikmati webinar ini. Minggu depan kita ketemu lagi. Terima kasih. Thank you for Dr. Raymond and all of the participants. Hopefully we can meet again for the next week webinar with the different tema. Terima kasih. Minggu depan kita ketemu lagi. Selamat sore. Thank you. Thank you. Makasih Pak Iyar ya.
Makasih juga Pak Jarot. Terima kasih Pak.
Ada Pak Suryantoro tadi tuh langsung hilang itu.
Ada tuh masih.
Ini Pak Susilo nggak kelihatan?
Masih ada sih, tuh ganteng.
Itu suaranya. Suaranya merdu kayak Afgan.
Oke, makasih Pak Jarot semuanya.
Kita ketemu lagi minggu depan.
Insya Allah.
Saya janji sama Pak Saru yang ngirim PowerPoint.
Terima kasih Pak Jarot.
Yuk, mari.
Terima kasih Pak Jarot dan semuanya.
Mari.
Assalamualaikum.
Waalaikumsalam.
Terima kasih.
Waalaikumsalam.
Itu link presensinya belum ada ya Pak?
Mohon izin,
Sudah tadi.
Ada udah tadi.
Mohon izin,